Question 3 says, draw each angle in standard position, then using special triangles required, determine the exact value of the trig ratio. So, standard position means they're talking about, they want us to put an angle like this, and essentially any of the acute angle in this position here. So they're talking about the first quadrant. Quadrant 1.
How do you know it's the first quadrant?
These are the numbers.
How do you know that they want it in the first quadrant?
Oh, because most of the time, or actually, sorry, all the time, when we start off figuring out angles, we always start from here. This is essentially our 0 and our 360 degrees. Okay? So
this is 90.
Yeah, and that's why the numbers are listed that way too. They're essentially telling you we go from 1, 2, 3, and then 4, and we're finished again. That's the idea for it. Okay, we got our numbers, 90, 180, 270. So a lot of our Cartesian plane is going to look like this now, C, A, S, and T. So these are the types of things we're going to want on it. Very first question says, using special triangles. Okay, so essentially what they're telling us too is these triangles we've drawn over here, we went over them just to start. I'm going to clean this one up.
So between here and there, that's 60 degrees? Like,
so, yeah, it's supposed to be,
yeah,
exactly.
Yeah.
It's supposed to represent it. You know, I may not have done it properly.
No, but that's like, okay.
Yeah. So we always draw from the bottom, right? We always come from the x-axis. So this is our 60 degrees. And actually what I'm going to do is I want to make this a solid line. So we have our 60 degrees. Now I can create a right angle triangle always out of that. I want that to be the dotted.
And how do you know, like, you can make it, oh, well, then that wouldn't be right.
Yeah, we always want to make it dead straight down to the x-axis,
Okay.
so that we create right angle triangles. That's the whole goal, and the reason we're doing that is so we can use our special triangles to solve this stuff. So we have 60 degrees, okay? So right away I know that I'm going to be working with that triangle there, okay? So if that's 60 degrees, that means my other angle here is 30. My hypotenuse is 2. Now opposite of 60 is root 3. And on the adjacent to 60 is the distance of 1. So I've already, out of just that one angle and the terminal arm we have here, I've created an entire triangle. Okay, that's the whole idea. So the very first question, the reason we use 60 is because A asked us for sine 60. So they asked us what is sine 60 equal to. Well, in our case, that's great. We have our angle, and we remember sine is opposite over hypotenuse. So we have opposite, hypotenuse. So the exact value of that is root 3 over 2. Okay, so we have our next question says 120 degrees from standard position. So we're here, 120, right? That's 120 degrees. It's an obtuse angle. Makes sense, greater than 90. Well, in order to create a triangle, you do the right step. It's got to come straight down. So I know this is 90 degrees. To solve this angle, I take 180 and subtract 120. What do I end up with? 60. Okay. Yeah. Now, a couple things do change in this, which also means this is 30. Our hypotenuse is still the number 2. Our adjacent side is now negative 1, because I'm in this part here. And we're still at root 3 for our y. Okay, question 4a tells us cos theta is equal to a half. Cos theta is equal to 1/2. Okay. So essentially, what I'm looking for is I got to go into my two special triangles here. Okay. Do either of the triangles deal with the numbers 1 and 2?
Yeah,
both, almost.
Oh,
this
well,
one's
the
root
second
2.
one.
Yeah. So the second one's, we're going to be working with this triangle then, because it has 1 and 2 involved. Also, cos, remember from our rules, is adjacent over hypotenuse, right? Exactly what we have written here. So I need to find an angle, and clearly it's either one of these two angles. If I did adjacent and hypotenuse from here, I would have root 3 over 2. Not what we're looking for. If I do adjacent over hypotenuse from the 60 degrees, my adjacent is 1, my hypotenuse is 2, I get 1 over 2. So cos theta, in terms of degrees, is 60. Okay? So we found theta is 60, not cos theta. So we discovered just by looking at our special triangles, theta is 60 degrees. Does that part make sense? Okay. Now, what they've done is they said determine the values, though, between 0, when theta is between 0 and 360 degrees. So we have our original one from our standard position. That's what we're looking at, is 60 degrees. Let's get a graph up here. So now what we're going to do is we're actually going to plot all the options between 0 and 360. So my options are this one here is 60 degrees, right? But I also have the option of that being 60 degrees, right? Remember, we always draw from the x-axis. I have the option of this being 60 degrees. Obviously, they're not drawn perfect, but that's the idea, is the sketch. And again, this is all between 360 degrees. So I actually have 4 answers to this question, okay? And the first one is 60 degrees. So we'll call the blue arrow. Blue arrow is 60 degrees. We got that. The black arrow is technically, because that's 180, right? Technically, the black arrow is 180 subtract 60 degrees, or in other words, 120 degrees. We're talking about moving from there. The red arrow is equal to 270, no, sorry, not 270 minus, because,
180 plus 60.
yes, very good, yes. The red arrow is 180 plus 60 degrees, which means we're working with 240 degrees, okay? And, which makes sense, that's all the way around there. And finally, the green arrow, we're talking about 360 subtract 60. So we take 360, subtract our 60 degrees, we get an angle of 300 degrees, which makes sense. With them starting from here, all the way around here would be 360 degrees. Now, the one other thing I did not talk about, clearly should have, is, we had found actually, I wrote all the options for 60, right? Well, we're going to have to actually specify which ones make sense in our answer, because we're dealing with cosine being a positive, okay? So according to our CAS system, CAST, the quadrants that cosine is positive in are in the 4th quadrant and the 1st quadrant, okay? So cosine is positive, cosine is positive, okay? Actually, in these two, these would be negative. So these two aren't actually options, our black arrow and our red arrow. They aren't options because in that quadrant, cosine is negative for both of those. So our actual answers, or where cosine is positive, are 60 and 300. So those are the actual two answers we're looking for. All right, we got to graph this wave and say we have no idea. I can actually start plugging in values of my x into a calculator to find out what the y value is going to be. Essentially coordinates. So let's say sine at, 0 sine is 0. So I know my sine wave is going to start at the origin. Okay. I could go halfway in between. Halfway between would be 45, right? So 45 sine 0.7. That's like somewhere here-ish, right? Let's do 90. Yeah, 90 is 1. Okay. I could do another 45 from there, which would be 135. That's what it's going to be. Same as 4.7, right? Remember, this is a wave, so it kind of slows down, and then it picks up in terms of steepness. 180 sine, do you know what it's going to be?
91. Yeah. Oh, and then 270
Is what?
-1.
Good. And 360?
0.
Good. So essentially, what's important is you get this in wave form. You don't just draw a straight line.
Yeah.
Okay? So that's the general idea of that. What about going back the other way? What's -90?
-1.
Yeah, good. -180?
0.
-270?
1.
Yep. And 360?
0.
So the wave continues like that. Should have done it in red. Sine is a red one, okay? Cos we'll do in blue. Y equals cos theta. It's a little different. Let's try cos 0, 1. So in other words, my cos wave starts at 1, okay? 90 cos is 0. 180 cos? Yeah, good. So if that's the case, what's 270 cos going to be? Yep. And 360? So our wave will go like that. Okay. And what about negative 90?
-1.
Great. Good. So we got this down. So this was a terrible wave. I'm going to fix that. So there's our, don't mind that little mistake there. There's our cos and sine. So we have our sine and cos waves. Those are the parent functions, the original ones. For each of the following, state the period. So the period is how long it takes to repeat a cycle. So for sine, essentially, if we start at 0, okay, and we're heading in an upwards direction, we want to know when we get to 0 again and are heading in an upwards direction. So technically, I get to 0 at 180, but I'm heading downwards at that point. We haven't completed the cycle. 360, I'm at 0 again, and I've gone up. Yeah, so essentially, the period of this function is 360. What is it for cos?
Cos is in blue, right?
Yeah.
1.
Well, remember, we measured in
I
what
mean,
degrees, right?
Um,
So cos's period will be, let's keep that same idea. Let's say we're at 1, and we're apparently heading in an upward direction before that. When do we get to 1 again?
360.
Yeah, 360. So it turns out the periods are the same for those two. Okay. Period. Amplitude. Amplitude deals with, first of all, finding the middle of the wave and how far it varies from top to bottom from that middle. So where is the middle of our wave right now for, let's say, sine?
180.
Well, let's talk about on the y-axis. Period talks about x-axis. That's a good point. We should talk about those. Period's talking about x-axis. Amplitude's talking about our y-axis. Okay?
Yep.
So where would the middle of the wave be in our y-axis? You can almost look at it sideways. What would be like a line right through the middle of that? 0. Yeah, 0. So if we're right at 0, okay, this is the middle. How far, we're talking about sine, does it go up and down? From 0. Yeah, it goes up 1. So your amplitude is 1 in this case. Okay, that's how far the variation is. It goes up an entire unit from the middle, and it goes down an entire unit. The middle will always have the same distance from top to bottom, so a peak and a trough, right? Do you remember those terms at all? Yeah. Okay, what about for cos? Same, yeah. Amplitude's 1 again. Equation of the axis, so that's the middle, okay? Equation of the axis, so equation of axis. Again, we're talking about a y value here. Equation of the axis is the middle. So what is the middle? We just talked about it. I feel like they should have rearranged the order of this question. What was the middle of both of ours? 0. So the equation of our axis is y is equal to 0 in both of these cases. Okay? Equation of the axis. And range of this function. What is the range of this function? Again, we're talking about y. We know that for range. Remember set notation for range?
No.
So we're talking about y is equal to all real numbers, right? So we have y is a set of all real numbers such that it's between what is the highest and lowest value?
1 and -1.
So -1, such that y is greater than equal to -1 and less than equal to y. Range of cos is the exact is a real number such that between -1 will fit and 1.